Hi friends, myself prabhakar, Assistant Professor in the Department of Food Science and Technology, NIFTEM, Sonipat. Today I'm here for a training program on cold chain logistics organized by Cold Chain Logistic Resource Center, CII and NIFTEM, Sonipat, which is funded by the GIZ Germany. Specifically in this module, I shall be discussing on the cold storage warehouse and its types. In the previous different modules, we have seen the requirement of the cold chain and different warehouses, and specifically, as we'll see, as per the capacity of different cold storage and the warehouses, we can see we can have the cold storage type 1, the capacity that is more than 250 metric ton, and the cold storage type 2, which is having the chambers not more than 6, and the capacity is around 250 metric ton. As far as the detailed design parameters are concerned, we can see in the cold storage type 1, each designed for single storage that is specific for the product, and the design for bulk long term storage, and specifically for the different products like potato, spices, pulses, etc. Storage has handling system for unpacked or soft packaged product or produce stored in bags or the bins, and that is specifically for the non-retailing packaging. In the cold storage unit type 2, the cold stores with more than 6 chambers, and each chamber of less than 250 metric ton in capacity, which is independent, which is having an independent room-based controls and the refrigeration system, which is capable of serving at different temperature zones, suitable for storing multiple temperature type commodities. We can also see, as per the different temperature range, that may be minus 18 degrees Celsius, minus 40 to minus 45 degrees Celsius, we can have the different way of an approach of storage, like frozen storage, under which the temperature generally we consider at minus 18 degrees Celsius and even lower. These are used for the processed food like ice cream, meat, fish, fruits and vegetable and its product as well. Freezing is mostly applied to meat and fish products, and in this case we can see that even the shelf life is quite higher. And the approach in case of the blast freezer, which is sometimes also we call it shock freezers. In this type of freezer, temperature bring down very rapidly and freezing the product very rapidly as well. Use blower fans which force cold air across the produce and rapidly chill the products, which can be understood in a mechanistic way. Okay, and the temperature goes up to minus 40 to minus 45 degrees Celsius in a very 4 to 5 hours. Storage types, we can continue the same concept over here. In the refrigerated storage concept, preservation of perishable foods and those that must be preserved cold to delay microbial activity. In most of the products which are generally stored at the refrigerated storage, why? Because to delay or to slow down the microbial activity and the other enzymes which are present in the food in order to increase the shelf life of the products. Refrigeration is the most used in fruits, vegetables, juices, bakery products, etc. And the requirement temperature which is ranged between 0 to 5 degrees Celsius. The storage types, we can continue the same concept over here. In the refrigerated storage concept, preservation of perishable foods and those that must be preserved cold to delay microbial activity. In most of the products which are generally stored at the refrigerated storage, why? Because to delay or to slow down the microbial activity and the other enzymes which are present in the food in order to increase the shelf life of the products. Refrigeration is the most used in fruits, vegetables, juices, bakery products, etc. And the requirement temperature which is ranged between 0 to 5 degrees Celsius. In the continuous manner, there are certain prerequisites before going for the freezing and the deep freezing the products. In order to enhance the efficiency of the cold room and even other or warehouses, we can go for the pre-cooling concept as well, and which is actually actually defined in terms of that is removal of filled heat immediately following the harvest. Because some of the fruits which contains fruits and vegetables which contains filled heat. So without removing the filled heat, if you store for some hours, this filled heat can damage the products. So to ensure the greater shelf life as well as to reduce the effort of actually the warehouse and the freezing equipment, we can go for the pre-cooling in order to increase the overall efficiency. As filled heat accelerates the deterioration and senescence process, and which can be also understood that the deterioration is very fast at a high temperature of 1 hour, and which we can see that the temperature may be delayed by 1 degree Celsius and even 10 degrees Celsius as well. The technique used for the free cooling, we can have the room cooling, forced air cooling, hydro cooling, vacuum, slurry or liquid ice concepts. So these are the different concepts which we can use for pre-cooling purposes. Forced air pre-cooling is the most applied technique and is customized to many perishable food materials. We can see in this picture the forced air cooling system, under which specifically it is well designed for the fruits and vegetable. The different fans are there and which are responsible for forcing the air, and that will try to take out the filled heat which is available in the fruits and vegetable. There is one video which we can see, and we can understand the forced air cooling system as well. The advantages of the pre-cooling. So there are different advantages of the pre-cooling process. It removes the filled heat, reduces the rate of respirations in the ripening, reduces the loss of moisture, reduces damage during the transits, reduces the production of ethylene, inhibits the growth of spoilage organisms, and eases the load on the cooling system as well, which I discussed in the earlier slide as well. The above factors, all these factors help in extends the product shelf life. Pre-cooling depends on the following factors. So in this slide specifically, we'll try to understand what are the different factors which are directly and indirectly affecting the efficiency of the pre-cooling concept. Air temperature during harvesting, that is during summer pre-cooling time, is more, and in that case the field heat may be higher. So this is also one of the factors which actually influence the pre-cooling efficiency as well. Time between harvest and pre-cooling, definitely. Nature of crop, which can have even the high perishable crop require immediate pre-cooling, because the field heat which is available in the product can damage quickly. So difference in the temperature between crop and the cooling medium, nature and velocity of the cooling medium as well, rate of transfer of heat from the crop to the cooling medium, type of packaging, material used specifically for the products as well, use of waterproof ventilated boxes for good air circulations in the room is helpful, plastic boxes, fiberboard cartons which have been treated with the wax while render them waterproof as well. Mechanism of pre-cooling. Heat transfer mechanisms, that is generally in terms of the conduction and the convection, and in terms of the products we can see the potato, apples, cauliflowers, orange and other fruits which is having the bigger mass and the less surface area, and the vegetables require more time to pre-cool. Produce which is having smaller mass and the large surface area like lettuce, green onion, carrot tops, peach, corn, Brussels sprouts. So these are having actually the large surface area. That is why the heat transfer would be fast in this case. The rate of cooling depends on the individual volume and the exposed surface of the product as well, which are in principle is also valid in terms of the heat and mass transfer. Generally we do a study either in case of the large surface area products or even in case of the less surface area, and that also depends upon the smaller mass and the higher mass as well. Heat within the crop comes in two ways. If you see how the heat is coming in the products and how it is going out, because these two concepts will help us to understand actually the mechanistic view of the pre-cooling concept as well. Through the convection from the surrounding air, mainly from the sun in the form of the radiation. For example, a crop harvested in the early morning will be cooler since the sun has not been able to warm the surrounding air or crop and lower metabolic heat as well. From the metabolic heat from the chemical reactions within the crop, which is generally responsible, built in terms of the respiration as well. When the heat is removed by way of evaporating cooling, then the fresh produce must not be sealed in moisture-proof film like polythene bags. Otherwise, it will definitely affect the pre-cooling efficiency. Storage types. After pre-cooling, the main concept, how we have to store the products and where to store. So in the pack house, the pack houses are used for a small lot sourcing of the horticultural produce, and these are built nearby farming area. The different components of the pack house, that is also, you can find out from the figure which is displayed in this slide. And the components, the receiving area where a covered shaded area for the produce arrival. This practice is generally executed over here. A sorting and grading area. Next, a sorting and grading conveyor belt for manual picking and the choosing of the produce. Washing and drying lines if required. Mechanized drying and the washing line. Packaging area. This is specifically for where the produce is packed for further operations, and other electricity generator section and the components might be there, which are actually having the important role in supplying the power to the different machines and the components. Pack house, vegetable sorting, grading, and packing process, which we can see over here in this slide, and this video, which can actually explain us to understand how it is happening. Okay. In this specific slide, we try to understand the mini units which is having the less capacity and walk-in cold stores, which is generally used in the restaurant, supermarket, hotels, where fresh, frozen or pre-cooled products are need to be stored. In walk-in kind of cold stores, generally have footprints smaller than 3000 square feet, enclosed and refrigerated storage spaces which are available for this. These are located at distribution centers as well, and the temperature range is in between -18 degrees Celsius to -22 degrees Celsius. Right? In the next slide, we will try to understand the controlled atmosphere cold stores and modified atmosphere stores. These two stores specifically for where we need to manage the composition of the gas as well. And this is used for some specific fruits and vegetables and for eliminating pest in stored grains and oilseeds. Most important applications are for the apples, pears, sweet cherries, cabbage. CA and MA are used primarily for disinfection rather than for increasing the shelf life. If you'll see how it is acting, how it is working, so the principle of this specific storage type, it is used to reduce the rate of respiration, reduce microbial growth, retard enzymatic spoilage by changing the gaseous environmental surrounding the food products, which I even said earlier that it works on the gas composition changes as well. Low O2 and high CO2 levels slow the ripening process, stop the development of some storage disorders such as scald in apples, and slows the growth of decay organisms. As we can see, the higher oxygen actually responsible for the higher ripening, and at the same time if we maintain the high amount of CO2, then it will try to slow down the ripening process as well. So both will be in contradictory nature. So in general, in principle, what we do, we maintain the low oxygen percentage and the high CO2 levels in order to slow down the ripening process, which in turn increases the shelf life of the stored products. The differences of if you see the differences between the CA and MA, the degree of control of gaseous composition of a storage atmosphere, this is the most important differences which you can see. CA implies a high degree of control than MA in maintaining specific levels of O2, CO2 and other gas. MA, in which atmosphere is generally created and maintained by interaction of the commodities respirations with the permeation of respiratory gases through the packaging material. Pulling slight vacuum and replacing the package atmosphere with a desirable gas mixture, which can be further adjusted through the use of O2, CO2 or ethene absorbers. In CA, uses of low oxygen levels and the high carbon dioxide levels in the storage atmospheric and refrigeration system. Uses of oxygen that lies between 1 to 10% and carbon dioxide 0 to 30% concentration, and the balance is supplemented and maintained by the nitrogen. Used for long-term storage of fruits and vegetables like apples, pears, kiwi, cabbage, etc., and which is for up to 10 months. In this slide, we will try to understand benefits and limitations of CA and MA. The quality, in terms of the quality advantages, first one, reduction in chlorophyll breakdown with resulting high color stability. Reduction in geometric browning in cut produce, especially fresh cut produce, agricultural produce, whenever low level of oxygen are used. Improvement in texture caused by the action of CO2 on enzymes acting on cellular membranes. Next one, reduction in some physiological disorders induced by C2H4, such as scald of apples and pears, chilling injury of citrus fruits, avocado, chili pepper, and okra. Next, reduction in microbial activity, especially modes which are obvious. The marketing and distribution advantages are, first one, reduction in fresh food spoilage and quality loss through the distribution at the retail level. Second one, expanded radius of distribution system and the market area. Next, improved branding options and product differentiation. Next, potential for increased profitability in all fresh or chilled food operations. Benefits and limitations in the same manner. So, in these situations, the last one, in terms of the potential problems which we can actually see, the first, the health hazards, favor of anaerobic microorganisms, specifically for anaerobic non-proteolytic toxin producers such as Clostridium botulinum, are likely to have the right conditions for optimal growth. Development of off-flavors due to accumulation of ethanol, acetaldehyde, and other volatiles. Increased softening in products such as the cucumbers, cauliflower, celery, and the onion, which are not actually desirable for our agricultural producers. Development of physiological disorders such as brown stain on lettuce, internal browning and surface peating of some fruits, and black heart of potatoes induced by the inappropriate modified atmospheric conditions. Increased susceptibility of some products such as celery, carrot, pepper, Chinese cabbage, and citrus fruits to the post-harvest pathogens as well, which are really highly vulnerable in this case. Now we try to see what are the different actually methods for creating and maintaining the MA. Okay, so reduction of oxygen levels, how we can do through respiration of food product up to 25 days, replacing the atmosphere of a storage space with desired gas mixture. Rapid oxygen reduction is obtained by either nitrogen flushing or by catalytic combustion. In addition, O2 absorbers may be used, for example, dithionate, ascorbic acid, alkali containing glucose, hydrogen gas in the presence of palladium catalyst and iron based products. Modified atmosphere packages are dynamic system where respiration and permeation occur simultaneously. Factors, if you see, which are affecting gas permeability through the package include type, thickness, surface area, the packaging film, as well as the temperature, relative humidity, and the gradient of CO2 and O2 in the sealed package. Now we'll try to see the same storage conditions, that is controlled atmospheric storage of the cereals and the oil seeds. Environment that is lethal to a stored grain. Waste is created by changing the proportion of CO2, O2, N2 from external sources, possibly prior to the buildup of infestations, thereby preventing damage to the store. And this is specifically we are discussing about the cereals and oil seeds. That we do understand it has no much correlations with the lower temperature and the freezing temperature, but in the context of C and MA, we will try to understand what is the gas compositions which are required for the cereal and oil seeds, and how in terms of composition how it is related in the case of low temperature controlled atmospheric storage as well. So the advantages for the CA storage of cereals and oil seeds: the potential to replace pesticides used in the grain industry. Second, CA treated grain does not have any chemical residues. In addition to providing an effective control of pests, CA storage prevents mold growth, preserves grain quality, maintains a high level of germinations in the stored grain. If you see the limitations of this CA storage for cereals and oil seeds: high initial cost of airtight storage structures, cost of generation and the transportation of the gas, which is also one of the can be the limitation. Okay, increase the internal pressure on beam walls. Carbonation of concrete, steel may eventually corrode and weaken the storage structure. Quality changes in grain under CA storage. So we can see in terms of the seed viability, grain can be stored for relatively long periods without a loss in viability. Factors which affect longevity are moisture and temperature, with each 1% increase in seed moisture content having the life of seed. Above rule applies. I mean, these all rules can be applied when seed moisture content is in between 5 and 14%. Below 5% moisture content, the speed of aging may increase because of auto-oxidation of seed lipids. And above 14% moisture content storage, fungi kill the seeds. I mean, it can spoil and it can damage the seed. That is why generally we maintain the low moisture content, and that is specifically in between 5 to 14%. We'll try in this slide specifically. We'll try to see the nutrient changes in the grain. A CA, that is controlled atmospheric of 97 to 98% nitrogen, 1 to 2% CO2, and 1% O2 slows hydrolytic process in the lipids of rice grain compared to grain stored in air. Pure nitrogen atmosphere at 20 degrees Celsius stabilizes protein and amino acids, and cooking properties of rice at 18.4 and 23.2% moisture content. Elevated nitrogen with negligible O2 retain higher gluten quality in stored wheat. Milling and baking properties of wheat are maintained longer in air even at higher moisture content. An anoxic environment slows down the oxidative activity and better preserves the organoleptic property of the grain as well. Now, the effect of controlled atmosphere on fungi and mycotoxins productions, specifically for the grains. Elevated CO that lies between 20 to 60% inhibits fungi and the production of mycotoxins in fungi in a stored grain, including T2 toxin, botulin, ochratoxins, ancelic acid, and aflatoxin. In dry grain, 20% CO2 inhibits microflora. In wet grains, 80% CO2 is needed. Filamentous fungi gradually disappear during this storage, which can we can consider as one of the good benefit. Fungi do not grow at less than 1% O2. Yeast can survive at 0.5% of O2. So now the ripening chambers. So this is one of the storage type as well. Though we'll try to understand in details in the other module, where specifically the ripening chambers and its mechanism will be covered in details. So ripening chambers specifically for actually the last mile facilities in the cold chain, and it is one of the component in the cold chain, designed to function for controlled and hygienic ripening of fresh fruit, so that any environmental contaminations and other factors which cannot damage the fruits during the ripening process. The components of the ripening chambers can be considered as the insulated chambers designed for short-term storage and mild chilled. The temperature lies between 16 to 25 degrees Celsius temperature. Independent refrigeration equipment to maintain mild chill temperatures for ripening. Ethylene or other FSSI approved ripening dosing systems which are also available, and airflow designed to allow for even a spread of dosing gas, temperature control, and ripening in the chambers, because the dosing of gas and the temperature, which are very important factors in the ripening of the fruits. And these are associated gas compositions like associated air freshening or ventilation systems, which are also considered to be one of the important components in the ripening chamber. Material handling equipment for handling incoming and outgoing loads. The next, electrical control panel to monitor and control the ripening process that may be correlated with the temperature, airflow, dosing of different gases as well. Now, at the last, we'll try to see the different conditions for their storage and the range of temperatures, and these temperature range which are applicable for the different agricultural produce and the food products. So, the temperature requirements for the frozen, where the temperature is generally minus 18 degrees Celsius, and which are applicable for frozen vegetables, fruit pulp, pineapple slices, ice cream, meat and fish products. Now next we'll see the normal conditions where the temperature greater than 20 degrees Celsius, but it is nearby. The onions, dehydrated foods, roasted foods, sun-dried products, pickle, jams, jellies, ready-to-eat food, oils and extract as well. The next one for the chill temperature, which lies between 0 to 10 degrees Celsius. The fresh fruits like apple, pears, the fresh vegetable, potato, carrot, raw and pasteurized milk, butter, eggs, dry fruits, nuts, dry chilies. Mild temperature that lies between 10 to 20 degrees Celsius. Subtropical, which are applicable for the subtropical fruits like mango, banana, dairy products like milk powder, chocolate seeds. So in this module, we tried to know the different storage temperature conditions, and accordingly what kind of different storage structures are available and the warehouse are available for the different products. So I hope that through this module definitely we will be able to understand the different storage conditions as well as the warehouses for different food products. Thank you.